This is problem number 4 on the sample test problems for test number 2. A computer password is made up of 6 characters. Each of these characters can either be a letter, A through Z, uppercase and lowercase letters are considered to be the same, or a digit, 0 through 9. Don't worry about simplifying your answers to this problem. A, how many different computer passwords are possible? So in this case, I guess the first question I'm asking myself, is repetition allowed? Meaning as you fill in your 6 different characters, are you allowed to repeat the same character? And since there's nothing in the problem saying you can't repeat, then we have to conclude that repetition is allowed. And as soon as we decide that repetition is allowed, we must use the multiplication principle or the multiplication rule, as opposed to, say, using permutations or using combinations. So the first question we ask to decide how to count something, is repetition allowed? And if the answer is yes, automatic, you have to use the multiplication rule. Okay, I've got 6 characters, 1, 2, 3, 4, 5, 6. I'm going to figure out how many choices I have for each of the characters, and I'm going to multiply all those numbers together. So each character can either be a letter, and there are 26 of those, or a digit. It's tempting to say there are 9 digits, but there's actually 10 digits because the 0 counts. And so altogether we have 26 letters plus 10 digits is 36 choices for that first character. Any letter or any digit, there are 36 things to choose from. And all of the characters are equal in this part of the problem, so every one of these is a 36. So let's see if we can get a number. Maybe it's too big, we'll see. So if I do 36 to the 6th power, I get that enormous thing, which I don't feel like writing down, but anyway, that's how many possible passwords there are. Then B, how many possible passwords start with a letter? Same idea as before. We're still going to multiply 6 numbers together. And most of this is exactly the same. It says how many possible passwords start with a letter, meaning that everything else except for the starting slot is still 36. There's no other restrictions down here. But the first one has to be a letter. So how many choices do you have in that first slot if it has to be a letter? Well, the only choices are letters, and there are 26 of those. So we can't put a digit there, which is why we've lost those 10 digits to choose from. And so if we wanted to figure out what that one is, we could do 26 times 36 to the 5th. There's only 5 36s now. So we should get some still enormous but smaller number. Part C, how many possible passwords consist entirely of letters, no digits? Okay, I feel like we're doing pretty well here with multiplying these things together. And we want entirely letters, no digits. That means that each choice we have only the letters to pick from, and there are 26 letters throughout. So all the way down, multiply all those 26s together. And if we wanted to see what that is, so this one will still be enormous, but quite a bit smaller than the answers up above. And then finally, part D. A password is randomly generated by the computer. Assume that all possible passwords are equally likely. What is the probability that the password consists entirely of letters? Okay, so let's write down our definition of probability in English, and then we'll fill in the numbers. So we know that the probability of something happening is a fraction. It's the number of ways the thing can happen divided by the number of ways anything can happen. So it's the number of passwords of some flavor up on top divided by the number of total passwords on the bottom. So to fill in the rest of the top, we have to decide what's what's considered a success here. We want the probability that the password consists entirely of letters. So the top is a number of passwords with only letters, no digits. So again, our definition of probability is the number of ways that the thing can happen divided by the number of ways that anything can happen. So I think we've translated that to this password problem. And now we have to fill in the numbers. So the number of passwords with only letters, well, that's exactly what we found here. So up here on the top, we have 26 times 26 all the way up 26 to the 6th divided by total number of passwords. We found that in the first part. It was all these 36 multiplied together. So the denominator of this fraction is 36 to the 6th. And that answer is fine, but if you actually wanted to see what it looks like in terms of a proportion or a percentage, we'll go ahead and type that in. 26 to the 6th divided by 36 to the 6th. And as a percentage, if we multiply by 100, turns out if a computer just randomly generates a password, there's about a 14% chance that the password will have only letters, no digits.